Algebra 2, this is test 4 study guide, everybody. Logarithmic form we're writing from. This is exponential form. You want to write it as log. Remember, this is going to be your base, the first number. Log base 4 of 64 equals what it's being raised to, 3. Remember, this is backwards of the way we learn. It's not a superscript like that. It's just equals 3. This is backwards of the way we learned it, but you can go forwards to backwards. You can go from exponent form to log form and back. You could write that, again, as you read this, you read it as log base 4 of 64 is 3, and you could just say it's 4, since it's base 4 of 64 is 3, and it'll look like that. But that's what we started with. This is log form here, or logarithmic form. These are evaluating the logarithm. It says logarithm base 3 of 1 over 81. Remember, this is a fraction. It's at the bottom of the fraction. It's in the denominator, so you're going to have to ride the elevator. Remember, the only way to make it ride the elevator is to use a negative exponent. First, though, is you want to change the base of 81. You want to make it the same as base 3. So if you have your charts, look at your chart on the left, go down to 3, and just move on over to where you see the number 81, and you'll see that 3 to the 4th power is 81. So this rewritten would say log base 3 of 1 over 3 to the 4th power, okay? Again, that's still not evaluating it all the way. We just made the bases the same. In order to make it in order to make it go up, or in order to make it ride that elevator, you need to raise it, the whole thing, to the negative 1 power. Okay, that'll make it ride the elevator, and it'll look like this. Log base 3 of 3 to the 4. 3 to the 4 is supposed to be bigger. 3 to the 4th is now raised to the negative 1 power. It's over 1 raised to the negative 1 power, which doesn't change what it is, or it'd be to the 1st power. In fact, it's raised to the negative 1 power. That's what made it ride that elevator. So now you have the same bases. Log base 3 of 3, they cancel each other out. And you have 4 times negative 1 because you're raising a power to a power, and you simply have negative 4 for that one. Log base 6 of 1296. Again, this one's a little bit easier because you got one less thing to do. You don't have to worry about the elevator itself. Just look at 6 on the left-hand side. Move on over to 1296, and you can see that when its base is 6, 1296 is 6 to the 4th power. That's changing its base to 6 to a power. Again, this is what logs are about, making big numbers into small numbers. So what this is now is log base 6 of 6 to the 4th. And again, since these are the same, they'll eliminate each other, and you're left with the number 4. Number 4 gives you a decimal form, and it doesn't show you what the base is. We had base 3 for number 2. We had base 6 for number 3, but it doesn't show you what the base is for number 4. So it's understood to have a log base 10. So log base 10 when it doesn't show anything, okay? Also, when you're dealing with decimals, it's much simpler to change them into fractions. Okay, most of us hate fractions. I know everything in you about math class would go so much smoother if fractions didn't exist. But this is one of those instances where they're much easier to do. This is simple, though. Take and see how many places the last number is. This is the 10th place. This is the 100th place. So what that number is 1 over 100. That's the same thing. So we have log base 10 of 1 over 100. So we can see that we want to make the number 100 into base of 10, just like we made the last two numbers, 81 and 1296, into different bases. So the number 100 is the same thing as 10 to the 2nd power. So we still have log base 10. And again, you can condense some of these steps. You don't need to write everything. I'm just talking step by step so everybody can follow. We don't want it 1 over 10 squared. That won't allow us to eliminate it. We need to make it ride that elevator and go back up. So just like on number 2, we're going to raise it to the negative 1 power. We'll raise this whole thing to the negative 1 power. Now we have log base 10 of 10 squared being raised to the negative 1 power. Now you have the same bases, log base 10 and log base 10, and you're raising the 2nd power to the negative 1 power, multiply them. 2 times negative 1 is negative 2. Number 4 and 5, just doing polynomials. Make sure you only add and subtract the like polynomials. Number 5 and 6. 5 is easy because they all have like ones right across. 6 has a little hang up because there's one missing. We'll see in a second. 7w squared minus 8w squared. So 7 minus 8. 7 minus 8 is negative 1w squared. Then you have negative 6w minus 3w. Negative 6 minus 3 is negative 9w. Notice we are not adding the exponents. We're just combining the coefficients. And then negative 8 minus a negative 7. Remember, minus a negative means plus a positive. So negative 8 plus 7 is negative 1. This is all we can do with this polynomial because they don't have the same like terms. For number 6, always start with the largest degree, which is u to the third power. We have 5u to the third plus 8u to the third. Unlike number 5 where we were subtracting, we're adding these, so you don't have to worry about changing signs. 5 plus 8 is 13u to the third. Then you have 6u squared. The next biggest degree is 6u squared. But notice there isn't a u squared in the other one. So you'll simply put plus 6u squared. If you put it together with negative 2u, make sure you make that change. Okay. Then the next degree is negative 2u. That's this one here. There's only one of them. So negative 2u. And finally, the constant terms, 4 plus 2 is positive 6. Number 7 says to simplify the product. Multiply the coefficients by each other, distribute it. 6 times 4 is 24, and 6 times 4 is plus 24. Also multiply the variables. X to the 7th multiplies by x to the 3rd. Remember, anytime you multiply the same variables, x and x, same bases, you add the exponents. So you get x to the 7 plus 3, which gives you 24x to the 10th. The other one, though, when you look at it, is x to the 7th again times y to the 5th. That's not the same base, x and y. So you simply write it as 24x to the 7th, y to the 5th. You cannot put those two together and get the number 12. And that is considered simplified. Number 8 tells you negative 8.1 to the 0 power. Anything to the 0 power is 1. Number 9 tells you 2 is being raised to the negative 5 power. A negative exponent tells you to ride the elevator. It becomes 1 over 2. It's now to the 5th power. 2 to the 5th power is 32. So it's 1 over 32. 3 over c to the negative 5th, d to the 5th. C to the negative 5th is raised to a negative exponent. It has to ride the elevator. 3 is not. 3 can stay at the top right where it is. C goes up to the top and becomes c to the positive 5th. D is raised to a positive as well, so it stays on the bottom as d to the positive 5th. You cannot subtract c and d or divide those because they're not like bases. You can't subtract 5 and 5. This is all we can do with this. Number 11 says 3 to the 0 times 3 to the negative 2 times 3 to the 5th. All three of those bases are the same, 3, 3, and 3. When you are multiplying the same bases, 3, 3, and 3, you could add 0 plus a negative 2. We know that means minus 2 plus 5. So 0 minus 2 is negative 2, and negative 2 plus 5 is 3. So we have 3 to the 3rd power. We know 3 to the 3rd power is 27. 6.75 to the negative 6 times 6.75 to the positive 6. Again, same base, 6.75 for both of them. So you add the exponents, 6.75 to the negative 6 plus 6. Negative 6 plus 6 is 6.75 to the 0 power. And again, anything to the 0 power is 1. X to the 6 times 3x to the 11th. 3, x to the 6 times x to the 11th means 6 plus 11. 3 x to the 17th. 6x to the 5th times 3y to the 8th times 5x to the 6th. Multiply 6 times 3 and get 18, and 18 times 5 and get 90. So you have 90 when you multiply those three numbers by each other. X times y times x. Remember, it doesn't matter what order you multiply in. When you multiply the same base as x and x, the first and the last one, you you add 5 plus 6. The y to the eighth does not add to them because it's different than x. So it's simply y to the eighth. So to simplify this, we have 90x to the 11th, y to the eighth. 8h squared to the third. Everything inside that parentheses, even though it's a monomial, there are two things there. Everything gets raised to the third power. 8 gets raised to the third power, and h squared gets raised to the third power. When you raise a power to a power, you multiply the exponent. So unlike when you're multiplying same basis, instead of adding 2 plus 3, we're multiplying 2 times 3. So 8 to the third, again, you can use your chart, it makes it a little bit faster, is 512. And h to the 2 times 3 is h to the 6th. When you multiply the same bases, you add the exponents. In this case, for number 16, we're dividing the same bases, x and x. So you subtract the exponents. X to the 4 divided by x to the 7th is x to the 4 minus 7. That gives us x to the negative third. Remember, you can't leave a negative exponent. It has to ride the elevator, and it goes down to become 1 over x now becomes to the positive third. Remember, there's a shortcut with that, like on number 17 when you're dividing the same bases 4 and 4. You know that you're going to subtract them. You know that 9 is a bigger number than 6. So you subtract 9 minus 6 and you get 3. And you put that number down there where the bigger number is. So that's 1 over 4 to the third. Again, 1 over 4 to the third. You can look at your chart. 1 over 4 to the third is 1 over 64. Again, you could have written it as 6 minus 9 and gotten 4 to the negative third on top, then rode the elevator to get 1 over 4 to the positive third, then 1 over 64. But if you could see the shortcut that I just talked through, it'll just save you a little bit of time. Number 18 says c to the 7th, d to the negative 9th over c squared, d to the negative 4th. Again, dividing same basis c and d and d. You subtract the exponents. C to the 7th minus 2, just like that, is going to be c to the 5th. D to the negative 9 minus 4. It might hurt you to try to do the trick right here since you're doing minus a negative. So just to be safe, write them out. C to the negative 9th minus a negative 4. You might lose the fact that that means plus a positive. When you do that, you get c to the negative 5th on top. That's not c, excuse me. That's d, everybody. D. You get d to the negative 5th on top. And again, since you have a negative exponent, it has to ride the elevator. C to the 5th stays right where it is because it is not raised to the negative exponent. But d to the negative 5th goes down and becomes d to the positive 5th. C to the 5th over d to the positive 5th. 3b over 4 squared. Everything is going to get squared. 3 gets squared. B gets squared. And 4 gets squared. So 3 squared we know is 9. B squared we don't know what that is. And 4 squared is 16. The only thing you would have to do at this point, if you can reduce 9 over 16, if there were a number that you can divide both of them by, you would do so. But you can't in this case. So that's simplified. Number 20, solving this equation. In order to solve a quadratic equation, it needs to be equal to 0. So in order to get rid of 36 or move 36 over, it was positive, you subtract it on both sides. You have to do it there and here as well. So what we have is x squared plus 12x plus 0, there's no more because 36 minus 36 would be 0, is equal to 0. Now, if we were completing the square, we would get rid of it and we would find a new c value. There's no reason to do that in this case because you can look, there's a binomial on the left and they have a common factor. Their common factor, there's an x in both of those terms. So if you take the x out, then you ask yourself, what do I need to distribute x to get both of those terms? X has to multiply by x to get x squared because you add 1 and 1, and it has to multiply by positive 12 to get 12x. So x times 12x equals 0. We're almost finished. It tells you to solve it, not just to simplify it. So in order to get equals 0, something has to be equal to 0. So this x has to be equal to 0, or this x plus 12. Most likely both of them is equal to 0. So x is 0, or get rid of plus 12 by subtracting it on both sides to get x is negative 12. So those are your two answers that go with that quadratic. Number 21 says negative 4y minus 11 is equal to negative 2 times y minus 7. Distribute negative 2 first. Times this is negative 2y times this is plus 14. Negative 4y minus 11 is equal to that. Okay. You have y's on both sides, but it's a linear equation because it's to the first power. So you undo that by moving the smaller 4y over to the larger negative 2y, or the smaller negative 4y. It says negative or minus 4y, add it to that side. If you add it to that side, add it to this side. Negative 2y plus 4y is positive 2y. We still have plus 14 there, and we still have negative 11 on the other side. Since we brought our y's to the right side, let's bring our 14 to the left side. It's positive, so subtract it. When you do it there, do it here. Negative 11 minus 14, they have the same sign negative in front of them. So add 11 and 14, and you get negative 25. Keep that common negative. 25 is equal to 2 times y, and to get y by itself by dividing by 2. If you do it there, do it here. You know that a negative divided by a negative is a positive. This is a negative divided by a positive. So it's going to be a negative, and there's no number that goes into 25 and 2. So we'll leave it as the improper fraction, negative 25 over 2. Factor this expression. Remember, you're factoring a trinomial into two binomials. Separate the a value by multiplying x times x. Then factor your c value. C's value is 12. That means 1 times 12 is one pair. 2 times 6 is another. And 3 times 4 is another. Which one of those pairs gets you to b's value is the next question. B's value is what's multiplying by x. It's negative 1. But let's just focus on the fact that it's 1 right now. Which pair out of those 3 pairs on the right, when you add them together or subtract them or combine them, whatever term you want to use, will give you the number 1. If I put 1 and 12 together, I either get 11 or 13, depending on if I add them or subtract them. If I put 2 and 6 together, I either get 4 or 8 by adding or subtract them. That's not 1. And if I do 3 and 4, I either get 7 or the number 1. That's the number I'm looking for, the number 1. So we have to use 3 and 4. So we're almost finished with factoring this. The last step is to determine which signs are connected to what numbers. This sign in front of C either tells us they're the same sign or different signs. If it said plus, they would be the same. It says minus, that means they're different signs. And since they're different, this sign in front of B tells us the sign of the larger number. It says negative, so 4 is negative and 3 is positive. X plus 4 times x plus 3 times x minus 4. 23 tells you to write the number in the form a plus bi. There is no number that when you multiply it by itself gives you a negative 4. There's no real number, I should say. So we learned in order to make this mathematically where we can actually solve it, we have to take this and pull that negative out by multiplying it by I. So we still have plus 5 there. It says the square root of 4, which is both 2 and negative 2. So 2 and negative 2 is multiplying by I. I just changed the order right there. Plus 5. It tells us to say A plus BI. So A's value in this case is 5 plus or minus 2 times I. And again, the reason it's plus or minus, a lot of y'all missed this on last week's test, is because it's the square root. That's an even number. It's both positive and negative to get to 2. Had it been an odd root like the cube root, it would only be 1. Solve the quadratic by completing the square. In order to complete the square, you need a new c value, ax squared plus bx plus c. This c is no good. So undo it by subtracting 19 on both sides. Now you have x squared plus 8x plus c, we're going to find a new one in a second, equals negative 19 when you subtract it on both sides. A new c can be found by taking b, dividing it by 2, and squaring it. B's value is 8. So 8 divided by 2 is 4, and 4 squared is a positive 16. But remember, when you add 16 on one side, you have to add it to the other side of the equation as well. So negative 19 plus 16 is negative 3, combining those two. Now there's a perfect trinomial on the left. That means you can take the square root of the first one, x squared, which is x, and the square root of the third one, 16, which is 4. And the sign in front of b is what goes between them. So x plus 4 squared, it's a binomial squared, is equal to negative 3. In order to solve this, work your order of operations backwards. Please excuse my dear Aunt Sally. It tells you to add and subtract first. But since it's in parentheses, we can't get rid of plus 4. So we have to take care of all of that squared first. We know how to undo squaring something. We take the square root of it. That'll cancel this out, but we have to take the square root of that side as well. So what we're left with on the left is x plus 4 is equal to the square root of a negative 3. We said on the last problem that there's no number times itself that gives you a negative value. You need to multiply it or take the number I to take that negative out. So x plus 4 equals that. Then in order to get x by itself, get rid of plus 4 by subtracting it on both sides. You can't take it away from the number 3 because it's inside the radical. So x is equal to negative 4 plus or minus the square root of 3 times I, just to make it say a plus bi.